I suppose que you see, yes or no?
Yes.
Ok, entonces nada, I say que en 2D, que es XY, ¿no? Plane, too much. Each equation is represented by the line. Two equation, another line. Solution, see you need solution or no, you know the different possibility. So the three possibilities in linear system is one solution, no solution, or infinity many solution. In 3D, it's different because we have three axes, X, Y, and Z. And each equation is represented by the plane. Suppose the plane like that. Let me shape. Plane, plane, plane. Plane. Okay, and now it's more complicated because sometimes we have this the same three possibility, but it's a little bit hard to understand. No? And remember, when you have infinity many solution, we need to analyze the free variable, a classical, in the scenario of the infinity many solution. Okay, entonces today application. There are infinity application, but I try to cover the most important, no? Suppose this problem, application is very, very actual application because it's about the hospital, coronavirus, something, you know. A hospital using 15% bleach solutions to disinfect a quarantine area. How much 6% bleach solution must be mixed with the 18% bleach solution to make 50 liters of the 15 bleach solution? So to understand, I read that too much, I don't understand anything. However, to understand a little bit, I create maybe sometime, I don't know, additional sketch because one picture is much better than 1,000 words. So say now I try to put three square that represent the container, no? And this container is the container that has 6% concentration. You don't know how many liters of this we have this, no? Or we need to obtain this. Another container 18%, but I need to find the final answer that I want is this container that I need to obtain, que is 50 liters and 15% concentration. Okay? So now I suppose that we set out linear system of equation. Let me try. You organize the equation depending the category that we have in the problem, that basically is one category is, you know, volume in liter, no? Volume in liter, que we don't know here, I call X, we don't know here is Y, and here we have 50. 50, the unit is using in this to indicate the volume is liters. So es obvio que one equation is X plus Y equal 50. And this is my first equation. Look at the organization by row, and the column indicate by row with the category volume, and the row and the column, sorry, is the unknown, is the variable of our problem, no? Another category I see in the problem is the concentration, no? Concentration. In the concentration, we have three categories: 6%, 18%, and 15%. And make it sense if you mix it together, 6% and 18%, you put 6% and you have 18%, and it's logical according to the proportion that you mix it, you have intermediate value of the concentration of 15, no? Okay, for example, one stupid problem is you have 18% and 6% I want to put together to get 20%. This is totally illogical because you need to find, according to the proportion you mix it, and this, you get intermediate value between 18 and 6. Makes sense, right? Makes sense or no? Come on, communication. Answer me.
Yes.
Yes. Now, well, if you multiply 6, maybe in decimal or in percentage, 6 or 0.06, okay, it's in decimal, no? You divide by 100, no? You want to express this percentage, this is decimal, you multiply by the amount of liter that we have in this container. For example, I don't know, but I call X. So this quantity or this quantity indicate me somehow the amount of liter that we have in this container of the bleach solutions. Okay, let me try to explain this more clear. Suppose the container. In this container we have X liters at 6%. That means that 100% is the total volume of this liquid. However, 6% only is about pure bleach solution. And the rest, que es 94%, is pure water. Make sense? This is bleach at 100% concentration. It's mixed with the 94% of the pure water. No bleach, only water, and together generate the solution que is, I don't know how many liters at 6%. Make sense? Entonces the formula is easy. The formula is your multiplication, the concentration, so concentration, let me call capital C concentration, by the volume, and give me one thing, it's called, I don't know, let me call P. Okay, let me call P. So you multiply, and so now, what is the idea? You multiply in decimal or you multiply in percentage? Well, you the logical and the, you know, and the chemistry logic maybe is in decimal. However, I want to prove that it's totally irrelevant. Okay, suppose 0.06 represent the only the bleach in this container. To find the amount of bleach in the other container is 0.18. No? Why? Because it's a different volume. S equals something plus. So you adding both together, okay? This plus indicate mixed. This and this in the corresponding proportion is equal to the multiplication 50 liter times 0.15. So 50 times 0.15. The answer is 7.5. And 7.5 something que I suppose que es the total volume, pero specifically only the bleach. O sea, it's only basically we have one equation that represents total volume, including water, and one equation that is just the bleach, que es the second equation. Let me call equation 2. However, in my opinion, my personal opinion, it's easier in percentage. So this is 6x plus 18y equals 750, no? Because you multiply the equation 2 by 100, you know, because I want to express in percentage. And now you get the second equation. It's obvious, it's elementary, that both equations are linear dependent, no? The equation 2 and the new equation 2 is the same because you know very well it's the same line, it's a two-dimensional problem, it's the same line. They are dependent, so it's equivalent algebraically, no problema. Either way, so you like working with the decimal, it's okay. So you like working with the percent, it's okay, no problem. Okay, so now when I finish, I understand the problem. I set out the equation, the rest is apply our strong, powerful algebra. It destroy everything. It's a machine. It destroy any problem. We focusing now in the algebra part. I want to copy again the equation. Look at the organization. It's important in the organization. You put equation in a standard form. What means standard? Equation 1, equation 2. This is a system I want to solve it. Standard is when you have ax plus by equals c. You organize in this format. A is a constant, b is a constant, c is a constant, x and y is a variable. And normally I appreciate so much, not strictly mandatory, but I appreciate so much that a, b, and c are integer number. No decimal, no fraction. Okay? If you have decimal or fraction, when you multiply by the corresponding least common denominator, and you remove the fraction or the decimal. Okay, there are many infinity ways to solve this. Well, infinity, no. We have two ways, substitution or elimination. Okay, some students say, no. I like substitution because I take advantage that the coefficient here is 1. Oh, cool. So, and now I can solve for one variable and plugging in the another equation. Well, another student say, no. Professor, no, I don't like this. I like apply elimination maybe, and you multiply the equation 1 by a factor that we need, que is negative 18. Multiplication by negative 18. For example, because I want to get negative 18y and positive 18y and ready to be ready for elimination. Entonces now it's up to you what way you prefer, elimination or substitution. Come on. Elimination. Okay. And elimination, maybe you multiply the equation by negative 6, but okay. Let's do it by negative 18. Because I did in my paper, like that. Multiplication by negative 18, the entire first equation. So we have a negative 18x minus 18y equal 50 times negative 18 is negative 900. And this is my new equation 1 after the multiplication, no? Entonces we focus now in this system. I a little bit ignore my first equation. Okay, ready. It's ready to add in equation 1 plus equation 2. Now this is negative 12x. This is canceled out. Nice. I like. That was my intention, no? And this is negative 150. Okay, subtraction 900 minus 750. Now finally divide by negative 12 both sides, because my goal is solve for x. The answer is 12.5. Okay, 150 divided by 12. We check with the calculator. 150 divided by 12, 12.5. What means 12.5? What is that? What unit is this? This is the second. This is the strawberry. This is the mile. This is the mile per hour. What is 12.5? What does it mean that? What is the unit for this quantity? Because it's a word problem, no? That's a word problem when you compute something. A liter, of course, it's a liter. It's a liter because we are talking about volume. Now to find another volume, que es the concentration 18%. Well, you plug it in either equation. I suppose that the easy way is plugging in the original first equation, que es super easy. Entonces, x plus y equal 50. But now I discover que x is 12.5 plus y equal 50. Therefore, y alone is 50 minus 12.5. Que the answer is 37.5. Liter again. And this is the answer. So you mix it 12.5 liters of the 6% concentration plus 37.5 a liter of the 18% to get 50 liters. And make it sense. Let me check it, double checking. 12.5 plus 37.5 is 10 carry that 1. This is 9, 1 is 40 and 1 is 50 liters. And checking the concentration. Not necessary to do this, but this is your word problem, and to make sure that I don't want to make a mistake because it's dangerous for the hospital, no? I double checking. I checking in the equation 1, que was the concentration. I checking in the equation of the concentration or bleach equation, que is 6 times 12.5 plus 18 times 37.5 should be, I claim this statement or no, 750, no? 750. Entonces ahí put in the calculator, this is 75. I put in the calculator, this is 675, is equals 750, and 750 equals 750. It's okay, and our answer is perfect. This answer is correct. This answer is correct. Any question? Do you understand very well or no? It's easy. I try to bring no big deal problem because it isn't. Okay, the rest is common sense, guy. Common sense. Cool. Let me go to another word problem. It's super easy, super interesting. This is application. This is no chemistry anymore. It's a physics problem. It's about riverboat. Wow, riverboat traveling on a stream against the current. Wow. And take 3 hours to travel 24 miles. Wow. And the return trip downstream was the current taking 2 hours. Because it's in the opposite direction, que es downstream. Entonces, the current is in the same direction. Entonces, the current helped you to go fast. Now the duration is smaller, 2 hours. Find the speed of the boat in still water, so without current, and the speed of the current. So the situation is, we have a path, okay, that path have some inclination, no? And the river travel in this direction. So it's obvious que our boat travel in opposite direction. The current is obvious que is moving in that direction, current. Because it's the gravity, no? Like going down. But the boat travel against the current. This is the speed of the boat. Okay, in this case, they call X. And the current they call Y. Okay. Okay, call Y. Now. This is the distance travel was 24 miles. Okay. Now we have another situation in which you travel in opposite direction. Now this is X. Y stays the same. But when you go faster because the speed somehow is additional, and the current helped me to go fast. And the duration of the trip is just 2 hours. Okay, do you understand the problem? Yes or no? So remember. In order to set out the system, there are many ways. However, you put a row as a category. The category means maybe doesn't matter. I call in my piece of paper three quantity as a speed. Depending, no, it's completely optional. You set out the row or you set out the column. You can transpose the table. No, entonces now I need to make a decision what is the best way. Speed, distance, and time. and time. It's the three quantity most important involved in this problem. However, in the column run, we have two categories que is up and down. No? So you move it up, que is again the current, and you move it down, que is in the same direction of the current. Okay. And the problems, though, specification speed never, but I know very well que the formula que state relationship speed division distance divided by time. You are familiar with this formula, no? In high school, no? When you took physics in college? No? Not yet? Okay, so now, when you moving over, the distance is 24. So moving up is 24 miles. And the duration of the trip is 3 hours. Therefore, it's 8 miles per hour. This is the speed when you move it up. Important the unit, guy. Okay, in the word problems, the numbers, you don't indicate the unit, you don't do anything. When you move down, it's the same this time because it's the same trip. But in opposite direction, it's 24 hours, 24 miles, sorry. But the time is just 2 hours. Now it's 12 miles per hour. Yeah, at least we complete the first row. Look at the organization of the problem, guys. It's a table like that. And this, I want in one moment to introduce the super fantastic technique for solving the system of equation, linear system, of course, que es the matrix. The matrix look like a rectangular array of numbers, right? But okay, this is another chapter. And the distance is the same, que 24. In both trajectory. But the time, no, the time is different. The time is 3 hours. And here the time is 2 hours. Okay. I don't know if it's useful or not, my table, because the most important for me is not the table, sino the equation that allow me to solve this. So look. I discover que 8 miles per hour is the speed in this condition. In this condition, x que represent the speed of the boat in still water, no current, suppose que travel horizontal without current, plus, or no, plus, minus, because in the opposite direction is equal 8. And this is my first equation. And my second equation, I focus in this condition. In this condition is easy because it's plus. Same direction, yes, 12. Do you understand very well this system of equations that I create with the word problem? Okay. Now we apply our powerful machine of the algebra to solve any linear system of equations. What do you consider is the best way? Substitution or elimination? Yes, Clara dice yes. Substitution, Jenny dice substitution. Okay, another opinion, Jenny, another opinion. You are right, but not 100%. Bueno, we have 50-50, no? Substitution. Chelsea dice substitution, professor. Okay. But you see clear que in one equation we have negative y, and another equation we have positive y. Yes or no? It's ready for elimination. Yes or no? Without do anything. Oh yes, dice Jenny. Oh yes. If you adding equation 1 plus equation 2 by column, x plus x to x, and the y is ready to elimination, and this is 20, 12 plus 8, divided by 2, x is 10. 10 what? What mean 10? What is the unit of the 10? 10 is temperature, is Fahrenheit degree. What is the unit for the X in this problem? Mile per hour. And it represents the speed of the boat without current. And what about y? Well, you plug in 10 in either equation 1 or equation 2, the equation que refers. I suppose that I select, I don't know why, the equation 2. Oh, mile per hour. Yeah, mile per hour. We are talking about speed. This x and y, I suppose at the beginning, is a speed. Now, suppose I want to find the speed of the current. You select the equation 2, maybe. You know, I don't know if it's good. 10 plus y equal 12. Therefore, y is equal to 12 minus 10, que is 2. And again, it's 2 miles per hour. Oh, I make sense. Because the 1, 2 speed, x and y, is in the same direction. It's in the same direction. You adding 10 plus 2 is 12. When it's the opposite direction, 10 minus 2 is 8. Do you see now clear? And this speed is like the action que conditionally the time, que is 3 hours and 2 hour duration. Super cool. Do you understand very well or no? Yes, I understand. Wow. Bueno, entonces you are ready to solving problem using, of course, imagination. You need to practice. Therefore, in the homework of this chapter, I include a word problem. No? Let's see one word problem in 3 dimensions, because we have 3 variables, because we have 3 conditions. Application in 3D. And we can use an application in more than 3D. The only complication in more than 3D that we cannot represent graphically. No. However, you can solve it algebraically in more than 3 dimensions. But no, in this is 3 dimensions. Let me read carefully that problem and let me set up the equations and solve it, of course. Janet invested a total of $18,000 in 3 different mutual funds. Okay, this is account. I don't care. The name is not important. It's mutual fund is a morning guy. For example, every teacher in Miami-Dade College have one part of the salary. I put in mutual fund, and the Miami-Dade College pay extra money, and this two money together increasing my money. Okay, it's mutual fund. It's fantastic when you retire. She, because Janet is female, invests in 3 different, gets a bond fund that return 4%. Okay, I want to call X. X represent the money que Janet deposit, because Janet control this, and the account get 4%. This is the interest rate. However, in the first year, okay, 1 year, and an aggressive growth fund, because sometimes happen, okay, if you want to get more interest, this is like a stock market, not exactly a stock market, but it's one possibility. So you say to your financial advisor, when I want my money, you deposit it in one account that is not aggressive. Because not aggressive is good because you never lost the money. However, increase it too slow. Okay. However, deposit some money in the aggressive because increasing fast. And see if the interest is high and this specific account is increasing super fast. But in this case, unfortunately, no, decreasing is negative. This quantity I highlight is interest rate. Interest rate. Maybe a positive is going up or negative is going out. She lost money in the second account I call Y. And the third account, let me continue, reach, lost 8%. Wow, negative for the year. And the international fund, okay, return 2%. It's very, very small value, but it's positive. Janice, period. Okay, this is the situation. She has 18,000. She split the money in 3 parts. Not necessarily equal. No. X no equal Y, no equal Z. No. It's the unknown that you need to find. However, the problem say que Janet invest 2,000 more in the ground fund than in the other two fund combined. Wow. I suppose that this sentence give me the information to set out one equation. Okay, but I am not sure. Period. If she has a net loss, wow, she lost money. Okay, the situation sometimes happen, not always, but sometimes. For the year, entonces now the total money that she obtained is negative. She lost, net loss is $540. Okay, entonces we have 3 accounts, no? We have 3 accounts que represent in the problem X, Y, and Z. This is the money inside the account. And we have 3 like a category, no? Let me try to investigate. So you can set up the equation like the X, Y, Z. I prefer this order because normally this represents the column of the hour table, no? And the first one is the total money, total money. And the total money in our problem is 18, no? 18,000, no? Entonces my first equation, guys, is X plus Y plus Z equal 18,000. Make sense? This is my first equation. Okay, you split in 3 accounts. Account, instead of put here X, Y, and Z, you put the name of the account. Okay, the first is bond, phone. It's a bond. It's a name, bond. Bond number, no U, is bond, the bond. Bond. Like that, good. And the Y is the bad guy, que is the, what is the name? Aggressive. Uy, aggressive. Okay, how many repeated consonants? GG and SS. Wow, aggressive. And C is the international. It's the name of the column. And the variable that represents each column is X, Y, and Z. Okay, cool. And now, what is the second equation is the, let me call one name, no? Is the interest, que es basically multiplication, the percentage, or no percentage in decimal if you want, so you feel more comfortable at the beginning. After we're using the algebra, no? You multiply 0.04, get the percentage for the first account, multiplication by X. And this give me the information about the money que I obtain extra in this account. Okay? And the Y, unfortunately, is negative because the interest rate is negative. And the Z is 2, no? 0.02. I express it in decimal because in the right hand side I put negative 540. And this is my equation 2 according to the information given in the problem. I copy directly And after I put an elegant standard form to start the algebra. And my third equation, because you need three equations, let me try to read one more time this sentence. Janet invests 2,000 more in the ground phone than the another two combined. Oh, so remember that the ground aggressive something is y, no? O sea, my extra equation is extra equation should be x plus c equal y. Equal y, no. No, equal y, no. Equal plus 2,000 equal y. Let me translate this to the one common language. Okay, the typical, que es y, que was the account que you lost money, que Janet lost money. It's called ground fund, aggressive ground fund. He or she invests $2,000 more, and the word more indicate addition plus. And the two combining, so two together, x plus c. Makes sense? This equation makes sense? You understand? You set up the equation from the English test that you interpreted of the problem. Maybe it's not good to apply algebra right now, but I apply the fantastic machine of algebra to processing the information. Okay? My question is, do you understand the equation or no? Okay? Yes, Jenny said, yes, I understand. Okay, now ready. No, it's not ready. I copy. The processing is x plus y plus c equal 18,000. I don't touch this. It's nice. It's a standard. The second, no. The second, I multiply by 100. Because 100 allow me eliminate the decimal. Entonces 4x minus ay plus 2c equal minus 54,000. Equation 1, equation 2, multiplied by 1,000 means 2 additional 0. And the rest, well, I copy. X minus y plus z equal minus 2,000. Equation 3. The only thing I did in the last equation was I'm moving y because I need this format. The column of the x, look at that, boom. The column of the y, boom. And the column of the z, boom. Nice. In the right hand side, just a number without a variable. And this is my system that I need to solve it. Everyone follow me? And you forgot the money, and you forgot the problem, and you forgot your name. Now you focus in algebra. Okay, so far. Now, Chelsea, we are doing the most complicated part. The rest is piece okay for us. Remember how you solving the equation in 3 dimensions. Well, you pair two equations. For example, in my piece of paper, I pair the equation 1. I just copy again. Remember, guys, the organization is extremely important. Equation 1. Okay, let me make it zoom. And equation 3. You see? Yeah. Why? What is the logical idea? Well, because it's equation 3. Because I know very well it's ready. Exactly. This is the idea, Jenny. Once you are in the equation 1 and equation 3 together, it's ready for elimination. Double cancel out. I am smart. I try to do it the easy way. I don't want to complicate my life. X plus X to X. C plus Z to Z. And now 18,000 minus 20, no, 16,000. Now, this is equation 4. However, I realize that this equation you can divide it by 2, no? Because the factors are, you leave it like that if you want, no problem. But however, much better simplification, no, in lowest term. This is 8,000, and this is equation 4. Do you follow me so far? And now I taking another couple of equation. For example, in my piece of paper, I take the equation 1 again and equation 2. I copy exactly the same. 4x minus ay plus 2z equal negative 54,000. Equation 2. But then, entonces, there are many ways. However, I take advantage. The y, and remember, super important. Si you eliminate the y in the first couple, you must eliminate the y. So I take advantage. Que y positive here and negative here. Entonces, would be fantastic. Okay, I multiply this equation by 8. Multiply the first equation by 8. You multiply, you have ax plus ay plus az is equal, and multiplication 8 times this. Okay, my paper I seek it for 144,000. Let me check it out in my calculator. This you multiply 18,000 times 8. Oh yes, is 144,000. Okay, entonces I focus in this system now. Okay, it's easy because this is organized. You know, the organization is extremely important. This is 12. This is cancel, elimination. This is 10. And now you adding this and this. Okay, actually is 90,000. So you subtract the 144 minus 54. All right. 144, 30, 1, 2, 3, minus 5430. 1, 2, 3. Boom. 90,000. Okay, and leave it like that? No, I don't think so. You divide by 2 at least. Divide by 2 because this is, if you don't divide, it's okay. But the only disadvantage is that your number is bigger than my number, no? This is 6x plus 5z equal 45,000. And this is my equation 5. And you put together 4 and 5. And let's see what happened. I don't have idea. Something good happened. It was a 6x plus 5z equal 45,000. And this is equation 5. And this is my new system. I want to focus in the solution of this. Well. Elimination one more time, guys. You multiply, for example, or substitution, either way. But I like so much elimination. If you multiply equation 4 by negative 5, what is my intention? Negative 5 and positive 5 is ready to elimination. You have negative 5x minus 5z equal negative 40,000. And this is my new equation 4 after the multiplication. But now I am ready. You 6 minus 5 is 1x. This is cancel out, say goodbye. And this is $5,000. And what is that? I don't remember because I focus on the algebra. I forgot. But the important organization is declaré. X is the first account que represent the mutual funds. It's a mutual fund money. So Jenny no, Janet. Jenny is my student, my fantastic student. Janet split the money, the 18,000 that she has, put 5,000 in the account mutual fund. Something. All right, let me try to find the rest. Well, the rest is easy. You take advantage that formula. Look, that is the reason I never erase equations. And you solve for C. C is equal 8,000 minus 5,000. It's 3,000. C is 3,000. Is the money que she deposit in the third account, que is the international mutual something. And the another money, well, you take, in my opinion, the easy way is taking the first original equation, que is x plus y plus c equal 18,000. I have in my hand x and z. I need to find the y. Y is equal 18,000 minus 500 minus 300. 300 no 1,000. 5,000, 3,000. 5,000, 3,000, 8,000. It's 10,000. $10,000. She deposit, unfortunately, in the worst account. Okay. However, I want to check it. Yes, of course, I want to check it. It's obvious that the total money, I don't need to check it in the equation 1 because matching perfectly. Because 5,000 plus 3,000 plus 10,000 is obvious it's 18,000. But let me check in just in case in the question of the interest. What happened with the money? And the money is 0.04. This I plug it in this equation. This is not mandatory. This is to make sure. 0.04 multiplied by 5,000. Let me make it zoom that part. Minus 0.08 multiplication by y, que es 10,000. Plus 0.02 multiplication by 3,000 should be equal minus $540. You need to verify that this statement is true or no. Multiplication this guy and this guy, 200. Multiplication this guy and this guy is obvious, 800. Multiplication this guy and this guy is 60. And this is, let me see. Let me check it out. Yeah, 200. Oh yeah. This is 6 minus 600. Not necessarily calculated. Subtracting $60 is 540. Okay, I got it. This is the answer. She split her money in this account, in this account, and this account. And definitely this year she lost that money. Well, maybe next year because of the pandemic, maybe. But after the pandemic, she earned more money. Any question? Do you understand very well or no? Totally confusing? Of course, I cannot explain the infinity situation that we can face in the real life, but this is the idea. This is the idea. You organize the equation, letter by letter, condition by condition, and you try to create one table. There are no formula for the table, but this table look like a matrices. So a matrices, you have different column, different row, and you organize. This is a fantastic way to organize, and also it's a fantastic way to solve the system when you study matrices. No, no. It's a motivation for this moment. Any question? It's okay? I can erase the board. Or not yet? Erase or no? You copy? Yes. Let me ask you something. What is the way that you are doing in the lecture? You copy simultaneously with me in your notebook, or you are doing a screenshot, or when you're watching the video again, you are doing your own note in the notebook. What is the way that you are using? I copy, anyways, I copy as you do it. And another student, no. I respect anybody. I follow it in the notebook. Okay, no. I don't want. It's a way that you make a decision that you consider better for you. Okay, but I need, by curiosity, I want to know. Okay, this is the next topic, very important, very important, we study now, is using in calculus 2. Okay, in calculus 2, the professor que explain calculus 2 for you, suppose que you know very well that part. Okay? It's called partial fraction decomposition. Decomposition. Partial fraction decomposition. Entonces, what is the idea behind this? In calculus 2, you need to apply this. There are one method to do the calculus operator. Calculus operator. By the way, the calculus operator, operator much better. Operator is integral. The word operator, right? Operator, like that, operator. When you are doing calculus operator, specifically, one calculus operator is the integral. Okay, the symbolic way to indicate this is 1s long. There are one fantastic method is called solving this calculus operator using partial fraction decomposition method. Now you need to know what is that. So you need to know what is the idea behind this. Okay, let me try to explain. The idea is you have, for example, rational function p divided by q. Are you familiar with the rational function? And suppose that the degree, well, we have two possibilities. We have the possibility of the improper fraction, improper or proper. What is the idea improper and what is the idea of the proper? Improper is when the degree of p is bigger than degree of q. Okay. And when the proper is when the degree of p is less than or equal, no, less than, equal no. This is equal here. Degree of q. Entonces, when it's proper, it's ready. It's ready. It's ready to apply the idea that I want to explain now. It's ready. But when it's improper, not ready. No, it's not ready. It's not ready. But the only thing you should do is perform the long division. Long division. So you're doing long division now. Long division. Well, okay. So we have equation plus remainder divided by divisor. Okay, Q, no? divided to the cube. Okay, now that part, okay, for sure, 100% is proper, is obvious it's proper, is ready to apply partial fraction decomposition. And you take this like an additional part. Additional quotient, and this is ready to apply the partial fraction decomposition. Now, maybe you don't see too more clear now, but when you see the procedure, you understand very well. Suppose. What is the most typical partial fraction decomposition? What is the most typical partial fraction? Partial fraction. So we have four cases. The first is the most important, is when the denominator polynomial have real zeros, non-repeated. For example, one elementary example is, a over x minus 2 plus b over x minus 3. I copy a, b, and c because it's the typical coefficient. Okay, you put in the solution of the partial fraction decomposition. You put different letter a, b, c. You see now in the example. This is so far theoretical part, guys. Okay, I want to explain. No, I need to explain, I suppose. X plus 4. So you have, in this case, in the polynomial in the bottom, get q. You discover somehow that the factorization is x minus 2, x minus 3, x plus 4. So you separate in different, and you put in the top a, b, and c, que it's just a number, and degree is 0. Because in the denominator, the degree is 1. And together represent, when you put together, let's see it now in a few seconds, guys, it's equivalent to the original problem. Now, another is when you have real 0, but repeated. What means repeated? Repeated means multiplicity 2, multiplicity 3, repeated. So when they're repeated, suppose we have x minus 2 squared, is repeated. Multiplicity 2. You have x minus 3 not repeated. Okay, nice. Multiplicity 1. And you have x plus 4 multiplicity 3. Wow. So what is the format for the partial fraction decomposition? You copy x minus 2, but you copy x minus 2 raised to the second power and x minus 2 raised to the 1 power. You decrease in the power. 2, 1, 0. No, 0 is invisible. And you put a and b. Plus x minus 3. Oh, it's non-repeated. So now I put only one expression. But for a complicated guy, because it's QB, to say in the partial fraction decomposition, you divide this in 3 pieces. 1 x plus 4 cubic, x plus 4 to the second power, and x plus 4 to the first power. And you put another letter, D, E, and F. It's too long, guys. In calculus 2, there are one problem that the student, it's not hard, but it's long. And you spend 1 week doing that, or 2 weeks doing that, because it's too long. I want to explain another way. But slow down, be patient. I explain everything. We have one third case in which you have complex or imaginary, right? So in this case, you have, let's call it in the typical language of the partial fraction decomposition. We have 4 cases. Irreducible quadratic. irreducible quadratic expression. And suppose that we have one expression like that, x minus 3, and we have x squared plus 9. Wow, I know very well that x squared plus 9 is complex. We can factorization in the complex field, but in the real field, no. Now, entonces the typical format for the partial fraction decomposition is you copy x minus 3, you copy x squared plus 9, but here you put a because the thing is that the degree of the numerator is less than 1, the degree of the numerator. So in this case, si the degree is 1, the degree here is 0 is just a constant. However, this case, no, because the degree is 2, and thus the degree of the top is 1, and you put Cx plus D. You need to find two parameters, C and D. You call any name like A, B, C, D, it's just a name, and the goal is to find that. Okay? And we have one more scenario, complicated. Okay, you never find this, I suppose. If you have complex, but repeated. And complex repeated, let me try to find one example of complex repeated. Okay, suppose that we have in the denominator, so always the supposition that this is Q polynomial. It's a Q polynomial. I don't care too much P. When I suppose that P is 1 degree less than, that is a reason that proper fraction. It's a Q. And now the Q, and this is an area, is for suppose that we have x squared plus 4 a squared. Wow. So we have complex again, but a square, multiplicity 2. So now you separate into, the first one is x squared plus 4 a squared, and the second is x squared plus 4. And the coefficients are, for example, here ax plus b and cx plus d. Because degree 2, degree 1, degree 2, I don't care too much this exponent, and degree 1. Okay, now this is the moment to be ready to understand or try to do the example. I want to do the first example power in both directions to understand very, very well. You need to understand what means partial fraction decomposition and what is find the least common denominator. So you have two fractions, bam, and these two fractions have different denominator or not necessary, and you find the LCD and you condensing wrong in only one fraction. But the thing that we are doing is completely power. Is you expand this condensing fraction in several fractions. And this is super fantastic in calculus because the condensing look like super complicated problem. However, in one piece separately, it's easy computation, the integral operator. Let me show you. Suppose you have two partial fraction decomposition like that. What is my goal? It's 3. It's a given. My goal is condensing in only one. This is partial fraction decomposition. Somebody did that. Okay, nice. Now I want to do power. I need to condense it in only one. Then you find the LCD. The LCD obviously is x plus 4 times x minus 3. And you copy that. You copy the long line, you put x plus 4, x minus 3. The order is not important. It's a problem. Interchange the order. And now I'm going to find the top part. You divide mentally, this divided by this, and multiplication by this. You know that perfectly. It's elementary algebra. After you divide, and multiply by this. Let's do it, and multiply by this. Okay, let me erase this arrow because you know very well this action. So you divide mentally, LCD divided by the first denominator. It's obvious that this is cancelled out and stay alive x minus 3 times 3. You follow me? Plus, when you divide LCD again by another second denominator, es obvio que x minus 3 is cancelled and stay alive x plus 4 times 2. Okay, and now the rest is super easy. To apply distributive property, and why not combine like term? The 3x minus 9 plus 2x plus 8. The denominator stays the same. Now we combine this and this, like term f5. 5x and negative 9 plus 8 minus 1. I suppose that everyone follow me because this is elementary intermediate algebra. Yes or no? Cool. Now, Jenny, the new situation is backward. We are doing in opposite direction. In this direction, everyone understand. Now we are doing in this direction. In this direction is common denominator. And this direction is the partial fraction decomposition. It's equivalent to say expand. Okay, so now I have this information. I have no idea about this information. But I know that the polynomial at the bottom is formed by two factors. Okay, I appreciate so much this. Somebody knows, somebody need to multiply this. Or, sorry, factorization this. You separate in two partial fraction decomposition. One is que contain x plus 4, another is que contain x minus 3. And you call the coefficient that I have no idea, A and B. And my goal is find A and B. I want to explain two different ways to do this. And you see, no, it's easy in one way. Okay. One way I call funny way frame value. But sometimes happen that we have no frame value. In this example, it's straightforward. It's the first one. Yes, we have frame value. But in another, no. So we have a combination of frame value and system of equation. Okay, the idea, system of equation, linear equation. This is the idea behind this topic, you know, connecting somehow with the system of equation. Okay, so now what should I do? Well, you, first of all, you find the LCD. LCD I did before, no? Okay, but I suppose that I don't know that part. LCD is x plus 4 times x minus 3. And you multiply the entire expression bound by the LCD. It's obvious that in the left-hand side, stay alive only for x minus 1. Because these guys cancel out with this, and these cancel out with that. But in the right-hand side, we have A times x minus 3 plus B times x plus 4. You follow me? Well, at least we eliminate. At least we eliminate the fraction. No, I feel good. Yeah, I have no fraction anymore. Now let's use the technique of the frame value. Okay, fantastic. What is the frame, guys? Well, the frame guy is you, for example, you plugging in. You suppose. Let's do it. X equal 3 because I want. And that's it. Bueno, si esa es equation, I plug in. No necessary is, entonces now x equal 3 is a smart value, is a smart, frame value, is smart. A smart value, much better. No frame, no, smart. Let me call it smart. This is funny. It's a name that I create to explain this. Smart value. Why smart? Because when you evaluate here, 5 times 3 minus 1 is equal A. 3 minus 3. Wow, it's 0. This was the intention. B, 3 plus 4. So now we have 15. 5 times 3, 15. Minus 1, 14. This is 0. Say goodbye. No more. And 3 plus 4 is 7. Now to find B is super easy. Divided by 7 both sides. B is 2. Okay? Well, I need to find A. So say you create another smart value, que is let x equal minus 4. Because my intention now is eliminate that part. Negative 4 here, positive 4 is 0, is gone. So say 4, negative 4 is 5 times negative 4 minus 1 should be equal 8 times negative 4 minus 3 plus B. Negative 4 plus 4 is 0. Okay, that is the reason that's good. Okay, now we have 4 times 5 is 20, minus 20, minus 1 is minus 21. And the other side, we have negative 7. A, you divide by negative 7 both sides. Therefore, it's 3. A is equal to 3. And you see, this is the same answer we obtained in the example that we are doing in the other direction at the beginning. A, who is A? A is the coefficient, hypothetical coefficient I suppose, in the fraction that contain x plus 4, and B is the hypothetical number that is included in the top of the fraction that contain x minus 3 in the denominator. Do you see that? It's easy. It's easy. However, I want to explain another way, because sometimes happen that this is not easy. So we have no smart value for some reason that you don't understand now. But this is the complementary idea. So you apply smart. So you solving the problem, use smart, happy. But there are another possibility. So in this step, look, let me copy this step again. 5x minus 1 is equal A parenthesis x minus 3 plus B parenthesis x plus 4. You apply now distributive property. I bring down this guy. Distributive property. You have ax minus 3a plus bx plus 4b. Okay, now you condense it. No, you put together this and this like a common factor is x. Is x. X is a plus b. Okay, no good, no good, my. Okay, you see ax and bx, the common factor is x. You factorization is a plus b x minus, entonces you put 3a plus 4b, and you compare que the right hand side ab is a plus b is the coefficient in front of the x, entonces es obvio que a plus b is equal to 5, and minus 3a plus 4b is equal to negative 1, and we have equation 1 and equation 2. Okay, guys, you say, wow, professor, it looks like very, very complicated. Yes, I know, but the problem is that definitely in another problem, we have no smart value, and you need to use in this idea. Okay. So now what should I do? You multiply by 3, maybe. You multiply by 3, the equation 1, by 3 positive, no? Then we have 3a plus 3b equal 15, no? This is my equation number 1. And we focus in this system. Elimination, that part is 0. This is 7b. And this is 14. Wow, fantastic. Divided by 7 both sides, b is 2. Exactly, we predict. But this was easy. And this, okay, don't underestimate this, because we have in another example, no option for only doing by system. Okay, you try by smart value. I don't have a smart value. Or I have only one smart value, or two is not enough. We continue the problem. Of course, you continue. How we continue? Using system of equation. Now, one of the recipes, okay, because if B is 2, you come back to the first equation, entonces A plus B que es 2 es igual a 5, es obvio que A es 3. End the story. I finish. Clear or confused? Clear. Okay. This is just the beginning. This is just the beginning. This is the elementary kindergarten example. Let me try one similar, and you help me. And the second example is similar, very, very similar, no problem. But I want to introduce only one new idea. X, suppose in calculus 2, we have this equation, this rational function. I need apply partial fraction decomposition, PFD of this. What do you suppose I am doing? What is the first step? Or what is the step 0 to start? Opinion. I need participation. You don't say something? No problem. No, I don't know. I lost, totally lost. Okay, let me try. Gladys, Joseph, Chelsea, Gigi, Paisul, Edward, Jenny, Kyler, Andres, Natalie, Naidarli, Brianna. I'm not sure, but okay, give me some idea, Jenny, at least. Not sure. Jenny dice, I am not sure. But I need some idea. No idea. Es Joshua, Brianna, no idea. LCD. Pero before the LCD, Chelsea, what should I do before the LCD? You are doing something important. You say something important. She say, find the LCD. Pero you factorization the denominator expression or no? Oh, so I figured out the degree. No, the degree no. Degree is 2. Degree, exactly. Factor the bottom. Edward say, factor the bottom. Okay, to be ready to the partial fraction decomposition, I need to factorization always. The top no important, but the bottom yes. Bueno, es obvio que es 3 and 2, ¿no? 3 and 2 negative of. Correct? Correct? Now, who helped me to set out the partial fraction decomposition? Who helped me? Who helped me? Who helped me? Come on. I need more participation. Natalie, say something. You follow me, Natalie, or you are sleeping? Natalie? 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 My darling? You are here or no? Brianna? Wow. I don't like the student get silent.
Did you call on me, sir?
Yeah. What should I do? Exactly. Jenny say. Jenny say. Jenny say. Jenny say. You copy each factor separately. And you put totally arbitrary letter, A and B. Let me see in the piece of paper. Yes, I put exactly the same in my piece of paper. After that, what should I do? After that, what should I do? A ver, Chelsea dice LCD. Excellent, LCD. Chelsea say LCD. LCD es obvio que es x minus 3 times x minus 2. Put together. Two factors because it's different factor. And multiply everything times LCD. Es obvio que in the left hand side we have just x. In the right hand side we have 8 times x minus 2. B times x minus 3. Everyone understand this idea or no? It's important. It's easy, but important. So Natalie, definitely you are here in my class. I understand. Chelsea, I understand. Chelsea, help me. What is the next step? Because remember, my goal is find A and B, no?
So the next step, I think, is to make one of them either 2 or 3 to eliminate.
Wait, step by step. You say que maybe you declare a smart value. Smart value, not necessarily to put this name. This name is my name. In the book, you don't never say. You declare x equal to maybe, right? But one by one. Slow down. So 2 equal a times 2 minus 2 gets 0. This is the intention. And b, 2 minus 3 gets negative 1. So 2 equal, this is 0. Say goodbye. Hello, bye. And 2 minus 3 is negative 1. Negative 1b. Therefore, b alone is negative 2. Okay, now the next is 3, no? Positive 3 or negative 3? A ver, positive. 3 is equal a times 3 minus 2, b times 3 minus 3 gets 0. Smart value. So 3 minus 2 is 1, therefore a is 3. Entonces, this is super important. When you finish that, you find A and B, you declare the expression is given, professor, at the beginning. I discovered that one process gets called partial fraction decomposition. I put equal sign, you put here. S equal, A is negative, is 3, sorry, 3 over x minus 3. And B is negative 2, so you put the minus in either way, guys. There, negative 2, x minus 2. You can write, if you want, using the negative in the front and negative here is equivalent. I don't know, I prefer, in my mind, but it doesn't matter, it's my mind, no your mind, the minus here. Okay? It's the final answer. Any question? What part you don't understand? Guys, I like so much because the student ask me questions. Of course, smart question. So you ask me now, I don't understand anything, start at the beginning. I say, in funny way, the beginning was the syllable. Do you want to explain the syllable? No. Okay, do you follow me? A specific question is a smart question. General question, no, give me some clue. Clues less. What is the thing I want to explain for you? No good. You follow me? Yes or no? Okay, let's move on to the next question, more complicated. One more example, more complicated. Okay. This is x squared over x minus 1 squared and x plus 1. Oh, nice. I like this example because some guy give me a favor to do the factorization. The factorization is already done for somebody. Appreciate so much that favor. Because sometimes it's confusing. I need to apply scientific division, long division. Wow, it's too long. This is the problem of this. It's not hard, but it's too long. When the problem is too long, everyone, including me, maybe we make a mistake. And you believe that we spend 2 weeks doing the problem and you make a stupid mistake or the one stupid signs, and this stupid sign screw up everything. Wow, not good. So, the most important moment is you recognize what case we have. We have, remember, 4 cases. The first is real, non-repeated. The second is real, repeated. The third is complex, non-repeated. And the last one is complex, repeated. What do you think is this case? 1, 2, 3, and 4. It's 2. And the reason gets repeated is clear because it's multiplicity 2. These 2 give me information gets repeated. Therefore, how many partial fraction decomposition you believe that this expression have? We have 3, we have 4, we have 5, I don't know. 3. I need the order, guy. Suppose in my piece of paper, I put it like that. Not necessary in your piece of paper. It's x minus 1 squared. It's x minus 1 to the power first, que es invisible, and x plus 1. Entonces I erase the rest. It's only 3. And you put the letter that you want, A, B, C. It's a traditional letter that we use in this. But you put any letter, X, Y, Z. No, X no, because it's confusing with the variable. A, B, C is in alphabet order. What is the next step?
Professor, I have a question.
Go ahead.
Why do you have square at the first one?
Yeah. Our example means, what's your name?
Chelsea.
Our example have a square. That is the reason I put a square. This is the given problem. So the thing you need to understand is what is the decomposition for this problem. And when you see real repeated, you repeat 2 times. In the power original and subtracting 1. And si es 3, you put 3, 2, 1. In this case, 2 is 2 and 1. Clear?
Yeah, I see it. Thank you.
No problem. This is the typical question that I want to hear to clarify the idea, because I am no superhero to explain perfectly everything. I'm depending your mind, my mind and your mind. What is the next step? I'm lost. Help me. Guide me. What is the next step? I'm lost. LCD. Very well. Who dare to find the LCD? Please, who dare to find the LCD? Who dare? Remember the rule behind LCD. LCD is formed by the collection of the any factor of our polynomial, but when the sum factor is repeated, okay, by the way, x minus 1 is repeated to the second power and to the 1 power, you take the majority of them. You take the majority of them. And the minority, the minor quantity, not necessarily taken. This is the least common denominator definition. Okay, entonces, who help me? Who dare to find the LCD? Bueno, es obvio, ¿no? Es obvio que es LCD. Es the same guy here. Look. Yes or no? But you take this, not this, and this. So let me repeat one more time the rule of the LCD, it's clear, and this is, you suppose you don't remember, maybe some student, other student, yes, remember, but this is intermediate algebra, not this algebra. The idea is you take every factor involved in the problem, every take, don't mention any factor, and the factor gets repeated, you take the majority of them. So you have x minus 1 square, and x minus 1 and no square. And you take x minus 1 square and you ignore x minus 1 to the first power. The LCD obviously is x minus 1 square and x plus 1. You follow me or no? You understand very well this or no? Okay, so now multiplication. When you multiply, it's obvious that we have x squared equal what? Equal a times x plus 1, because in the first fraction after the equal sign, it's obvious that x minus 1 squared cancel out with this and stay alive this only, plus b, b what? b x minus 1 and x plus 1. Make sense or no? Because remember, our LCD contains x minus 1 squared, cancel out at least 1, stay alive, only 1 x minus 1 times x plus 1, plus c, x minus 1 squared. Everyone understand very well this algebra or confusing? This algebra is okay? This algebra is okay? Yes, Rachel. Rachel says it's okay. Now I try to do my best. Using the smart value, que I know que es easier. The smart value es obvio que es 1 and negative 1, I guess so, no? Pero let's do it one by one. Slow down. Because when you plug in 1, at least here, cancel out the c is going, it's gone, and the b is gone, I stay only a. So you have 1 squared is obvio que 1, and we have a times 1 plus 1, and 1 plus 1 is 2, therefore is 1 equal to a, therefore a is 1/2. Boom, found out. Okay, cool. Now, suppose another small value is negative 1. How do you know it's small value? Because you plug in negative 1 here, it's 0a, it's 0b, and this is no 0. It does allow me at least to find the c value. The negative 1, you replace x for negative 1. Be careful with the signs, because it's negative 1 squared. S equal, well, negative 1, when you plug it in here, disappear, that is going, it's gone, it's done, it's gone, and this is 0, no? Because negative 1 plus 1 is 0. So C, negative 1 and negative 1 is squared. Okay. Now negative 1 squared, 1 positive, and negative 1 together is negative 2, and negative 2 squared 4, 4c. Therefore, C is equal 1/4. Cool. I like that. Now, I have no more smart value. No, because the only value creates 0. A factor is 1 and negative 1. I have no more smart, but I using the frame value. Frame value. What is the frame value? We're completely arbitrary because we need only one more. So I like so much 0 because 0 is easy to understand, because plugging in 0 and you take advantage, okay, you know A and C. They need to find only B. Okay. The idea is plugging in 0. Arbitrary, guys. Suppose 100, but 100 more complicated. No? 0 is easy. And 1 and negative 1 was smart. And x is 1, x0 is frame. Maybe 2, but 2, maybe. You any value you plug in here and you solving well the equation, you get the same answer. But 0 is easy, because 0 squared is 0. No? And the first we have 1/2, que es A, 0 plus 1, plus big I don't know, and 0 minus 1 times 0 plus 1 plus C, que es 1/4, positive, no? Yes. 0 minus 1 is squared. No, 0 is 0, you know. And this is 1/2 plus, let me see, this is negative 1 and this is positive 1. So together is minus B plus negative 1 squared is 1 1/4, 1/4, 1/4, 1/4. Okay, now solve for B is easy. Well, first, if you want, you add in 1/2 plus 1/4. The LCD is 4. 2 plus 1 is 3/4. And therefore, 0 is equal to 3/4 minus B. Therefore, B alone is 3/4. I have the 3 value of the ABC. We need to express the final answer. The final answer. I want to explain different way to express the final answer. The final answer is final answer after the partial fraction decomposition I did before. A is 1/4. You put 1/4 x minus 1 squared plus 3/4 x minus 1 to the first power plus 1/4 gets C x plus 1. And this is a possible answer. Personally, I don't like, because I like much better like that. Look, let me show you. You copy 1/4 times x minus 1 squared. Oh, nice. I like that much better. You copy 3/4 times x minus 1 plus 1/4 x plus 1. More elegant, in my opinion. This is not just my opinion. Maybe in some book, leave it like that, it's okay. This is okay. In my opinion, this is super elegant. Do you follow me? Cool. Cool. One more example, and you let me know. And you let me know what case. So it's important. Recognize the case that we are doing, and I'm doing. And after I want to take advantage to explain another fantastic way to do this. Okay, suppose this. Wow, what the hell is that? Okay, my first question is, this fraction is proper or improper? Proper or improper? Proper. Good. How do you know? Because degree of the denominator is 3. When the degree of the denominator is bigger than the degree of the bigger no. When the degree of the numerator is smaller than. Okay? No equal. Equal no. Equal no. You need to do long division. In this case. Okay, good. Entonces proper. Si es proper, es ready. It's ready to apply partial fraction decomposition method. Okay, so what is the next step when you determine it's proper? Okay, it's important in calculus 2, you understand very well this, because the teacher put a crazy problem, and you know, no. This is rational expression, it's proper or no, or it's proper, yeah, this is possible doing, break it down, and partial fraction decomposition. Okay, what is the next step? What is the next step? What is the next step? Always gets the same. Next step. It's the same, always the same. Check it out on your notebook. No, before LCD. Exactly, factor. Entonces, very well, very well, very well, very well, very well. Entonces, you need to remember the formula for factorization different cubic. Que we study in elementary algebra. It's this formula. Okay, I recall. Now, in our specific example, we have two factors. We have two factors. We have two factors. One binomial, one trinomial. One binomial, one trinomial. Okay, and where you find that? Well, it's a cubic root. Cubic root x is cubic is x, and cubic root 1 is 1. And this is the same sign, negative, negative. And here is square first, always plus, multiplication both x and 1 is x, plus 1 squared is 1. Cool? Okay, okay, okay. And actually, directly, you obtain the LCD, because this is the LCD. And the LCD is x minus 1 and x squared plus x plus 1. Well, Professor, I don't understand one thing. What is the reason that you don't do the factorization of the trinomial? Well, because I know in elementary algebra that the trinomial is obtained for the difference of q is prime, and this trinomial is prime. How do you know it's prime, Professor? Because the solution is complex. And one fantastic way to verification is complex. You take, for example, this x squared plus x plus 1 equal to 0, and you apply the quadratic formula. However, not necessarily apply the quadratic formula, because you take a, b, and c, and you compute the discriminant, and the sign of the discriminant give me information about is complex or real. It's 1, 1, 1, no? 1, 1, 1. And discriminant is b squared minus 4ac. It's 1 squared minus 4 multiplication by 1 multiplication by 1. It's obvious that 1 minus 4 is minus 3. And when it's negative, it's because it's complex. Complex solution. That is a reason in the factorization it's impossible doing this. At least in the real field. In the complex, you know that you can. You study in the polynomial part now. But you don't need to do this, because you know that the answer is coming from the difference of q. The trinomial is always prime. And maybe you understand now why it's prime. Now you apply the case of the partial fraction decomposition. How many partial fraction decomposition you need to represent? How many? And which one? How many? No idea? Three. Which one? X minus 1 is clear, right? And this is, I realize now that we cannot factor this. Yes or no? Because I don't understand why you have two more. I suppose it's one more, no? X squared plus x plus 1. Yes or no? Yes or no? Okay. Entonces, what is, you put the coefficients A and B, or you put another format? A and B or another format? Is it correct format? Is it the case that we have one real zero, que es 1, but we have two complex? And the complex, I remember I explained that we have different situations. If the degree is 2, the degree is 1. Entonces, bx plus c. Cool? Cool? This is a typical format that you need to memorize for the partial fraction decomposition. You follow me or no? Okay. Now ready to be ready to multiplication the entire equation by LCD. It's obvious that we have 3x minus 5 only. We have a times x squared plus x plus 1. And we have b x plus c multiplication by x minus 1, correct? And we can using smart value or no? Or no? No. Why no, Jenny? Si you declare x equal 1, you plug in 1, that part disappears, yes or no? Because 1 minus 1 is 0. So you try to use it when it's possible. Do you see or no? Huh? So 1 is 3 times 1 is 3, minus 5 is negative 2, that part. We have here a times 1 squared plus 1, and this is 0. Because 1 minus 1 is 0. So actually, this is 3, a, therefore a alone is minus 2/3. Okay? And we have another smart value or no? No. You take the frame value. What is the most popular frame value? 0. X equals 0. X equals 0, plugging in. We have negative 5, no? Because you plug in 0 here. 3 times 0 is 0, negative 5. Equal, a, but I know very well that a is minus 2/3. I take advantage of this moment. And we have 0 squared plus 0 plus 1 plus c, b times 0 plus c, and 0 minus 1. Well, it's obvious that this is negative 5. This is obvious that it's a negative 2/3 because this is 1 and b is gone. Cool. And we have minus c, no? Minus c. Okay. So far, we have c in my hand. This is minus 2/3, minus 2/3. Okay, now manipulation. Entonces, I move c to the other side of capacity, minus 2/3 stay, plus 5. LCD is 3, is minus 2 plus 15. We come from 15, 3 times 5. This is 13/3. Oh, cool. This is C value, but it's negative or positive? Yeah, it's positive. It's positive. Okay. And we have no more smart value, but we can create infinity frame value. I'm using always a small value, no 100, no 1000, no 25, no negative 1. It's fantastic in my opinion. Here I have in my hand C. So the only unknown I need to find is B. Negative 1 is 3 times negative 1, plugging in here, and the original equation after the multiplication by LCD. Minus 5 is equal minus 2 over 3 parentheses 1 minus 1 because 1 is square, no? Like 1 minus 1 plus 1 plus parenthesis minus b because x is minus 1 plus c, pero c I know very well que es 13 over 3. Yeah. Multiplication by negative 2, no? Negative 2 because it's negative 1 and negative 1 together is negative 2. Okay, so my only unknown que I have in the problem is b. But it's easy. This is negative a because negative 3 and negative 5 is negative a. And this is, well, this is positive 1 and negative 1 cancel. The negative 2/3 times 1. And multiplication, why not? This is minus 2b. Minus no plus 2b. Because minus and minus positive plus minus, sorry, 26 over 3 is the multiplication of 13 times 2 is negative. Okay, so now we combine. So I put 2b minus 8 plus 2/3 positive. I move 2/3 to the left, maybe, plus 26 over 3 is equal to b. And we combine. LCD is 3, so negative 24 plus 2 no. Yeah, plus 2 plus 26, no? Okay, so this is 26 minus 24 is 2, and 2 plus 2 is 4, equal to b, divided by 2 both sides. It's obvious que b alone is 2/3. Because it's division, no? Entonces 4/3 divided by 2 over 1 is 4/3, and reciprocal 1/2, 4 divided by 2 is 2/3. Okay, so what is my final answer? What is my final answer? My final answer, I come back at the beginning. Look. My final answer is the partial fraction decomposition. Partial fraction decomposition is A. Who is A? I forgot. A is 2/3. Elegant way is minus 2 over 3 parenthesis x minus 1 plus, who's b? B is 2/3. So I separate 2x over 3 x squared plus x plus 1. And who is c? It's 13. So it's, you can write like that if you want, plus 13, because it's coincidence que the denominator is 3. It's the same. But in some problem, it's not the same denominator, you write like that. Plus 13 over 3 x squared plus x plus 1. Bang. And this is my final answer. You see? Okay, beautiful. Do you understand very well? Okay, don't worry too much. Don't worry too much, because this is the secret I want to share with you. And the internet, online, we have different software to perform algebra and another operation, and of course contain partial fraction decomposition. Problem, no? So let me copy. Let me try to explain the 5 minutes we have. The idea, see, I cannot. Well, we continue next class. For example, I open my browser. I want to share the screen, but no now. I open my browser. I try to find one site que es called Wolfram Alpha. Wolfram W. Wolfram Alpha. Okay. Now it is a moment to share the screen. Wolfram Alpha, Wolfram Alpha. Let me share the screen with the Wolfram Alpha. Oh, there you go. This is my browser. Do you see my browser? Do you see? I put in the here in the Wolfram Alpha is the name of the website. Wolfram Alpha is fantastic, guys. You open that and you go to the algebra. You have another science algebra. In the algebra, you select either example. Let me see I have rational function. Oh yeah, rational function. Okay. Compute the function, partial. Oh, partial fraction. Look at that, partial fraction. You select partial fraction. But no, don't worry for this too much. Because you put partial fraction or you put PFD, and they understand very well this. And our specific example we're studying right now was the polynomial and the top was 3x minus 5. I suppose you remember that. It's important the organization and the parenthesis. You enclose in one big parenthesis the polynomial in the top, 3x minus 5. Guys, do you see my work? Yes or no?
Yes.
And the bottom, I have x cubic. Cubic minus 1, no? Minus 1. Minus 1. Minus 1. And now you press this button, red button, compute the input, and you get this answer. Okay, this answer is equivalent to the answer we get behind, and we spend 20 minutes doing that. Is minus 2/3. Look at that, minus 2/3, minus 2/3, x minus 1. And the coefficient b was 2/3. Okay, copy here, 2/3. And the other was 13/3. Do you see that? Do you see it's equivalent answer? Okay, that is the reason que we are the best in Miami-Dade College, no? Together. Okay, so now one big problem que we spend 2 weeks doing in pre-calculus and calculus 2, we can check in at least if the teacher want to give you show you work, you have to do 2 weeks. If the teacher don't, so you break it down using this tool. And this is not the only tool that we have in internet. We have another tools, but I like this, Wolfram Alpha. Keep in mind, Wolfram Alpha, Wolfram Alpha. Okay, too much, guys, for one day, and we are leaving. Okay, bye-bye.